So now let's talk about the problem of the day. Be sure to answer the questions I ask out loud and think about how your work is the same or different from what we talk about together. How could we represent this problem visually? Explain your thinking out loud. Yeah, a lot of you probably said that we could use a tenths and a hundredths grid, similar to what we've been using over the past few days. That makes sense to me, right? We could shade 7 parts of this tenths grid to show the 7 tenths that Jackie vacuumed. I'm going to label that, we had 7 tenths, and that was for Jackie. Great. And then, like you probably also said, on the hundredths grid, we can shade 70 of those, and that will give us what Jordan vacuumed. So remember, every column is 10, so we got 10, 20, 30, 40, 50, 60, 70 hundredths. Great. That was for Jordan. Yeah, awesome. Okay, so who vacuumed more? How do you know? Say it out loud. Oh, interesting. They actually vacuumed the exact same amount, didn't they? When we look at the amount shaded on each grid, right, we can see that the shaded amount is the same. Huh. Well, why does that make sense? Say it out loud. Right. We know that every tenth is 10 hundredths. So if we have 7 tenths shaded, it would make sense that those 7 tenths would be the same as 70 hundredths, right? Each column here is 1/10 or 10 out of 100, same thing, right? And both models show that you've got 7 columns out of 10 total columns shaded. Okay, so let's make sure we keep this key point in mind. Read it with me. Go ahead. 10 hundredths equals 1/10. How do you know that 10 hundredths equals 1/10? Say it out loud. Right. A hundredth is 10 times less than a tenth. So it would take 10 hundredths, right, to make 1/10. Same thing. Cool. Okay, so I wonder if we could determine the amount that they vacuumed and show that it was the same using fractions. How could we represent these decimals as fractions? Say it out loud. Right? 7 tenths is 7 with a denominator of 10. 70 hundredths would be numerator of 70, denominator of 100. Yeah, exactly. All right then, how could I determine if these two fractions are actually equivalent? Say it out loud. Right. We know that if we multiply the numerator and the denominator of a fraction by the same number, we get an equivalent fraction. So we can take 7 tenths and we can multiply the numerator and denominator by 10. And that will give us the equivalent fraction of 70 hundredths. Cool. Okay, last one here. How could we determine if these decimals were the same using a place value chart? Say it out loud. Right, we could put them both in the place value chart. So 7/10, that's 0 ones, decimal, and then a 7 in the 10th spot. And how would I show 70 hundredths? Say it out loud. Right. Again, 0 ones, a decimal point, and then 7 in the 10th, 0 in the hundredths, means 70 hundredths. Okay, what do you notice? Say it out loud. Right. Both numbers have a 7 in the 10ths place. There's a 0 here in the hundredths place, but that's not actually changing the value of the number. It's just telling us to read it as 70 hundredths instead of 7/10. But 7/10 and 70 hundredths are equivalent. And again, why does that make sense that those two numbers would be equivalent? Say it out loud. Right. It all comes back to this idea that in every 10th, there are 10 hundredths. 10 hundredths make a 10th. So if you have 70 hundredths, that's the same as 7/10. All right, cool. 3 different strategies we can use. Visual model, right? Fraction, place value chart. Throughout all of them, what are we always needing to ask ourselves? Say it out loud. Yeah. Over and over again, it's something like this, right? Read it with me. How many tenths or hundredths is this equal to?